Hello, welcome to this video where we'll be learning how to derive the sum formula of a finite geometric series as well as an infinite geometric series. We are going to start with the finite one, and we want to get to this type of formula from some other mathematical procedure and process to help us get there. And the best point of departure is the Tn formula. We know that for a geometric sequence, it looks like this. The value of any term can be obtained using this formula. Suppose that we have a and r values, or we can get the position of the given value of a term as well. Okay, so similar to what I've done for arithmetic series, by expansion we know that Sn is T1 plus T2 plus T3 plus Tn minus 1 plus Tn. Okay, now if you sub in 1 here in the Tn expression, we know that that will be A. If you sub in 2, that will be AR. You sub in 3, that will be AR squared. Plus, if we sub in n minus 1 there, you have AR n minus 2 plus Tn is just AR n minus 1. Okay, so that is still our Sn expression. So what we're going to do now in the next step is to multiply the equation by r, okay, as a manipulation technique. So we have r Sn is equal to AR plus AR squared plus AR cubed plus AR n minus 1 plus AR n. Now we are going to call this equation 1 and we'll call this equation 2, right? Equation 1 minus equation 2. Why minus? Because we want that guy, right? So we have Sn minus r Sn. What will happen here is that we'll have A, right? That will cancel with that with that, and that with that, and that with that, and that with that. So you end up with A minus AR to the power n, right? Because all the other terms have cancelled out. By factorization here of Sn, we have 1 minus r. Factorize A, we have 1 minus r to the power n. Division both sides by 1 minus r. We can do that. There's a restriction on r, it's not equal to 1. So division by 0 is definitely not likely to happen. Cancellation there. So therefore we have Sn is equal to A 1 minus r to the power n over 1 minus r. And yes, r is not equal to 1. And that is the simple derivation process for a finite geometric series sum formula. Okay, now we're going to use this to get to the sum formula of an infinite geometric series. Okay, let's do that. Alright, so we have established that Sn is equal to A 1 minus r to the power n over 1 minus r. The condition that r is not equal to 1. So we want to derive the sum to infinity formula for an infinite geometric series. There's a restriction there. R is between -1 and 1, and really that means that the absolute value of r is less than 1. Let us extract this now and try to play around with that and see what that really means. Let's pick any number between -1 and 1. Suppose r is equal to 0.5. Okay, So we're gonna play around with different n values and increase them to see what really happens to the behavior of that power. Okay, or if you like, exponential function. Okay, so 0.5, let's say to the power of 10. Let's take out our calculators and test that. 0.5 to the power of 10, we get 9.765625 times 10 to the power negative 4. Let's go 0.5 to the power 20. We get 9.53674 times 10 to the power negative 7. Well, the value is decreasing, right? Getting closer to 0. Let's go to 100. 0.5 to the power 100 is equal to 7.888609 times 10 to the negative 31. How about 1,000? Oh, 0.5 to the power 1,000. This gives us exactly 0. Okay, so you remember that we talk about convergence of a geometric series and also divergence, but now this is telling us that there will be convergence, as of course the r is within the given restriction or the interval. It's between -1 and 1. So this is what happens when n goes to infinity. So if we go limit of n goes to infinity of r to the power of n, this gives us 0. Okay, so we're going to take this, plug it into this, and get the sum to infinity formula through that process. Okay, so sum to infinity will be the limit as n tends to infinity of this expression a 1 minus r to the power n of 1 minus r. Okay, now what then happens from here is that because this is the only power with the variable n and the rest are actually constants, that is what the limit will affect. So we know that as n tends to infinity, this will tend to 0 or will approach 0. So we end up with a 1 minus 0 over 1 minus r, which will end up giving us a over 1 minus r, and therefore that is our sum to infinity formula for a geometric series. Okay, easy, simple way of deriving this formula that we use in geometric series. Okay, that is basically it in terms of this video and working with the formulas just to know where they come from as well and what they mean. Okay, so this takes care of this video. Thank you so much for watching, and I'll see you in the next segment. Keep well.